Hi, it's Mr. Srikanth here, and in this video we're going to look at linear inequalities. And as usual, we're going to start with the key points. And so the first key point is that solving linear inequalities uses the same methods really for solving linear equations. And in particular what that means is that you should be doing the same thing to both sides or all sides of inequalities in the same way that you would for equations. The other key point is a really important key point where if you multiply or divide both sides by a negative, then you must change the sign of the inequality. So less than would become greater than, or less than or equal to would become greater than or equal to. Now, this is something that is sometimes avoidable, not always, but sometimes avoidable. And certainly in the Caledon Maths faculty, we tend to avoid having to multiply or divide by a negative if we can. And you'll see that in linear equations too. So I'll be doing these questions largely based on how we would normally teach this at Caledon. I might do one example both ways so that you can see the difference. So here's example one. Example one's fairly straightforward. The only difficulty with it is that it's got two inequalities rather than one. But either way, we need to get x on its own. When we're solving, we're trying to get the letter as the subject. We've got 4x here, we need x on its own. To get from 4x to x, we need to divide by 4. If we need to divide that by 4, we also need to divide what's on the other side of the inequalities by 4. And in this question there are two inequalities, a less than or equal to here and a less than here. So we need to do it to all three sides. On this side we're going to get -2 and on this side we're going to get +4. Note here, we divided by a positive number, so there was no reason to change the signs. We divided by +4. Okay, on to example 2. Now, example 2 is very similar to example 1. We've got 5x, we just want x. To get from 5x to just x, we need to divide by 5. And if we do that to the middle, then we need to do it to the right-hand side of the inequality and the left-hand side. Again, we're divided by a positive, so no reason we need to change the signs. And so we get 4/5 is less than or equal to x is less than 2. Okay, on to example 3. This time you've got a bit more work to do, but still exactly the same as if you're solving linear equations. We need x on its own. To get x on its own, we need to add 5 to both sides first, which will get me 2x is less than 12, and then divide both sides by 2, and we get x is less than 6. So that's example 3 done. On to example 4. Now you can see here that I've written example 4 twice. I'm going to do it first the way that I would teach this in my classroom and how I believe other Caledon teachers would teach this. This is different to what the PDF shows. So I would say to myself that the number of x's on the left-hand side is -5, whereas on the right-hand side there is 0. There are 0 x's here. And so there are more on the right-hand side because 0 is bigger than -5. And if there are more on the right, that means I need all the letters on the right-hand side. So I need to add 5x to both sides. So I would get 2 is greater than or equal to 8, add 5x. I'm trying to get x on its own, so I would subtract 8 from both sides. -6 is greater than or equal to 5x, and I would divide both sides by 5 to get x on its own. So -6/5 is greater than or equal to x. So if I draw this on a number line, 0's here, -6/5 would be over here. This is bigger than or equal to x. So any value of x has to be less than it or equal to it. So there it is on a number line. -6/5 is bigger than or equal to the values of x which are allowed. Okay, on the right hand side I'm going to do this the way the PDF shows, and theirs will have fewer steps, so they're going to subtract 2 from both sides, which will get negative 5x is greater than or equal to 6, and then I need to get x on its own, so I need to divide both sides by negative 5. And so we get x, and on the right we get negative 6/5. And then, of course, we did a division by a negative number here, and so that means we need to switch the sign around. Now, that step is so frequently forgotten that it's the reason why I try and avoid having to divide or multiply by a negative when I teach this. So I personally find too many students forget to change this symbol from greater than or equal to here to less than or equal to here. You can see, though, that without doing that, we'll get the wrong answer, because if I draw this on the number line, here's 0, here's negative 6/5, and with the inequality written the correct way, so less than or equal to, it says x is less than or equal to negative 6/5. So x can be any value equal to negative 6/5 or less, which matches the diagram I drew on the first section over on the left here. So you can see that when we do it by division of a negative number, we need to switch the sign around. And as I say, this is so frequently forgotten that I think this is a safer method, even though it has one more step involved, where we added the letters over to the other side to start with. Okay, on to example 5. So when there are brackets involved, exactly the same as when you have brackets in a linear equation, we would use the grid method to expand the brackets. So 4x subtract 8 is greater than 27 subtract 3x. Now, similar to the last page, I'm going to look at the number of x's on the left, which is 4, the number of x's on the right, which is negative 3. 4 is clearly bigger than negative 3, so my letters side is going to be this side over here, which means that I need to undo having these 3x's over there, and I undo that by adding 3x to both sides. And now I can focus on getting x on its own, which means I need to add 8 to both sides. And divide both sides by 7. And I'm finished. Obviously, at this step, if you were to subtract 4x from both sides, then you'd get negative 7x over on this side of the equation, which is fine. You can do that. There's no problem with that. And so long as when you get to getting x on its own, you end up switching the sign because you would divide by negative 7, then you'd be fine. Okay. So that concludes the examples. So now you should be able to have a go at all of the linear inequalities practice questions. Hope you get on okay with those, and look forward to seeing you on the next video.